Hello, this is the lecture number 1 for the chapter Triangles of class 10, and in this first of all we'll discuss the congruency. Now what is the meaning of congruence? Congruence means the two figures which have same shape and same size is known as the congruent figures, or the two figures are said to be congruent if they have same shape and same size. Same shape and same size. This is the meaning of congruent triangles or congruent figures. Now if triangle ABC is congruent to triangle PQR, then we write it as triangle ABC is congruent to triangle PQR. This is a sign for the congruency. Symbolically, in this case, A corresponds to P, B corresponds to Q, and C corresponds to R. And we write it like this. This is a sign for the correspondence. That is, A corresponds to P, B corresponds to Q, and C corresponds to R. Now, two figures, if they are congruent, then their corresponding parts will be equal. So, triangle ABC is congruent to triangle PQR, then their corresponding parts, that is angle A will be equal to angle P, angle B will be equal to angle CQ, and angle C will be equal to angle R. And the sides, side AB will be equal to PQ, side BC will be equal to side QR, and AC will be equal to side PR if they are congruent. Now, criteria for the congruency of the triangles. You have done this in your lower classes also. Sas Congruence Rule. Now, the two triangles can be congruent by the Sas Congruence Rule. Now, what this means, Sas Congruence Rules, if the two sides and the included angle between these two sides are equal to the two sides and included angle of the other triangle, then the two triangles are said to be congruent by Sas Congruence Rule. If the two side and the included angle of one triangle is equal to two sides and the included angle of the other triangle, then the two triangles are said to be congruent. Now then we have Asa Congruence Rule. In this, if the two angles and the included side of one triangle, two angles and the included side of one triangle are equal to the two angles and the included side of the other triangle, then the two triangles are said to be congruent by As Congruence Rule. After this, we have Aas Congruence Rules. Again, as the same thing. If the two angles and one side of a triangle are equal, two angle and one side are equal to the two angles and one side of the other triangle, then the two triangles are said to be congruent by Aas Congruence Rule. Now after that we have Sss Congruence Rule. Now if three sides of one triangle are equal to the three sides of another triangle, then the two triangles are congruent by this Sss Congruence Rule. Now RHS, Congruence Rule means right angle, hypotenuse and a side of a triangle. If the two triangles are congruent, if the hypotenuse and one side of one triangle are corresponding respectively equal to the hypotenuse and one side of the other triangle, then the triangle are said to be congruent by RHS Congruence Rule. That one should be a right angle in that triangle. Right angle triangle should be there, and hypotenuse should be equal, and any one of the remaining sides should be equal. Then the two triangles are said to be congruent by RHS Congruence Rule. So these are the criteria or the ways by which you can prove that the triangles are congruent. Now congruence means, I'm again repeating, that the two triangles are congruent if they have same shape and same size. Size which should be same and their shape should be same. Now suppose we have two coins of 1 rupee and 2 rupee. They are not congruent because their shape is same but their size is not same. Now if you take any two 5 rupee coin or 5 rupee note, then they will be congruent because they will have same shape as well as the same size. Now we are starting with the exercise 7.1, and this is the based on the congruency of the triangle. Now in exercise 7.1, read the question carefully. First of all, what is given in the triangle, what is given in the question and what you have to prove, and you have to read it very carefully. Now in question number 1, it is given that there is a quadrilateral ACBD in which AC is equal to AD and angle CAB is equal to angle DAB. This is given in the question, and you have to prove that the triangle, these two triangles are congruent. That is, the triangle ABC is congruent to ABD. See the order of this. Corresponding sides and corresponding angles should be equal if they are congruent, and the order of these triangles is very important. I have taken ABC, then the other triangle will be ABD because angle A is common, corresponding to angle A to A, and AB corresponding to AB of the other triangle, and like this. Now we are proving that the triangle ABC is congruent to triangle ABD. So you have to write like this. The triangle you are proving congruent, you have to write like this: in triangle ABC and ABD. Like this you have to write, in triangle. You have to write it in the beginning in which triangle you are taking. So I am taking the triangle ABC and ABD in which AB is equal to AB common and angle BAD is equal to angle BAC. This is given that this angle is equal to this angle, and AC is equal to AC. AC is equal to AD, it is given. Now side angle side. So side angle side, we have proved that they are equal. So these triangle ABC and ABD are congruent by side angle side congruence criteria, Sas Congruence Rule. Now when the triangles are congruent, then their corresponding parts will be congruent. Now because triangle ABC is congruent to triangle ABD, so we can say that BC will be equal to BD. BC corresponding to BD will be equal by corresponding part of congruent triangle. So when we have proved that the triangle are congruent, then their corresponding parts will also be congruent. So this is the question number 1 of this exercise 7.1. Now let us take the question number 2 of this exercise. Now in this it is given that there is a quadrilateral ABCD in which AD is equal to BC, read the question very carefully, and angle DAB is equal to angle CBA. This is given, and you have to prove that the triangle are congruent, and that is ABD is congruent to triangle BAC, BD is equal to AC, and angle ABD is equal to angle BAC. You have to prove. After proving that the triangle are congruent, now we can easily prove that the triangle are congruent by starting like this. We have proof. You have to write like this, and the triangle you are proving that they are congruent, you have to start like this: in triangle ABD and triangle BAC, and we are proving they are congruent. So in this, AB is equal to AB, this side is common to this triangle, and triangle DAB is equal to angle CBA. It is given they are equal, and it is given that AD is equal to BC. These three things are given. So by side angle side, these two triangles are congruent by side angle side. Side, this angle and this side, they are congruent by Sas Congruence Rule. Now because these triangles are congruent, you can write like that: BD is equal to AC, corresponding part of congruent triangles. When these triangles are congruent, then their corresponding parts will be equal. So BD will be equal to AC, corresponding part of congruent triangle, and angle ABD will be equal to BAC. Again, they are the corresponding parts of congruent triangle. ABD, this angle of this triangle, and angle BAC, this angle of this triangle are congruent, or they are equal by corresponding part of congruent triangle. See the order: ABD angle will be equal to angle BAC, corresponding part of congruent triangle. Now in question number 3, it is given that there is a figure in which AD and BC are equal perpendicular. This is BC and AD are equal perpendicular on the line segment AB. So it means they are equal as well as they are making the 90-degree angle. And you have to prove that CD bisect AB. CD bisect AB means that is CD dividing AB into two equal parts. That is, you have to prove that OB is equal to OA. This you have to prove. Now, how can we prove that they are equal? We can first of all prove that these two triangles are congruent, and then we can say their corresponding parts of congruent triangle are equal. Now, how can we prove that they are congruent? Now, it is given that AD is equal to BC. We are taking the triangle OAD and OBC. We are proving that they will be congruent. So, what is given? AD is equal to OB. It is given, and angle OAD is equal to OBC. It is also given. They are each 90-degree angle, and this angle AOD is equal to BOC. They are vertically opposite angles. This angle is equal to this. They are vertically opposite angles. So we can prove that. We can write that these two triangles, that is triangle OAD is congruent to triangle OBC by angle side, by angle side congruence rule. So when they are congruent, we can write that OA is equal to OB. Corresponding parts of congruent triangles, OA is equal to OB. So when OA is equal to OB, OA is equal to OB, so we can say that CD bisect line segment AB. So like this, we in this exercise 7.1, we have proved that up to question number 3, the triangle are congruent, and when the triangles are congruent, so we can easily write that their corresponding parts are also equal. Okay, we'll discuss the remaining question in the next lecture. Thank you.